and this is lecture number 2. And then last time we discussed about interference, huh? We talked about interference and then I talked about constructive and destructive. Do you remember the conditions that we found for the other ones? The Imax. What was the Imax? 2 type 1 plus 2 type 2. So was it there was a square?
Yes, sir.
Okay. What about the Imin?
2 type 1 minus 3 type 4.
Okay. So we talked about these things. So let's go to an application of interference. That is, if so, interference is basically waves coming from coherent sources, na? Yes. And if you did not look into it carefully, but we were up until now we were only talking about waves which were moving. We always had some kind of function which was something like this, x of plus or minus bt. Based on this, you could say either the wave was moving backward or forward, whatever. Okay? But what if you have this situation where you have two again coherent sources and then you have two waves but traveling in opposite direction? You remember the derivation that we did for resultant amplitude? In that I took the waves to be in the same direction. There was a kx minus omega t in the first wave and there is a kx minus omega t plus phi in the second wave, and they were both moving in the same direction, na? Because kx minus omega t occurred in both of them. Yes? So they were moving in the same direction. What if the waves are moving in the opposite direction? Then what happens? So let's take that case, and the topic is called the standing waves. Standing or stationary waves. So as I said, this is going to be an application of interference, and for interference we always had coherent sources. But now I am going to take two waves which are moving in the opposite directions. Huh? So what could be the wave equations? Y1 can be taken as A1 sine kx minus omega t. What could Y2 be taken as? A2 sine kx. Hello. Should be plus. Represents the other direction. Why should I write K and K1 and K2? Why am I not writing that? Why not K1 and K2?
Because they are not coherent.
Because the sources are taken to be coherent. Okay? So this is interference, application of interference. And in interference, if you remember, there were coherent sources. Let's take, for the sake of simplicity, let's take the amplitudes to be the same as well. Let's take them to be A0, A0. Then at some point they meet. And when they meet, then how is the resultant written as? By what principle do you give the resultant? Bolo.
Result.
By what principle do you give the resultant? कुछ भी नहीं रिवाइज करके आते हैं, बस उठ कर आ जाते हैं. Second bench. By what principle?
Y1 plus
पढ़ा था ना तुम लोगों को, कुछ रिवाइज करके आना नहीं होता है, then why do you use the resultant is given by y1 plus y2. That's yr. Then what is yr here? This y a0 sine kx minus omega t. We will try to understand why is it called stationary wave or standing wave later. First, let me just take two waves which are in the opposite direction and let's see what happens. Plus, A naught sine kx plus omega t. Then I think I can take this A naught common. Let's take this A naught common. Then this looks to me like sine C plus sine D formula. But what is that? Oh, yeah.
2 sin c plus d by 2 cos c minus d by 2.
2 sine C plus D by 2 cos C minus D. If I take that, then what will you get? You will get YR as 2A naught and then C plus D. So I should add these two. When I add these two, then I think omega t cancels. You will get 2kx by 2. When I subtract them, then I think I will get cos of minus 2 omega t by 2. But cos of minus theta is cos theta. So I can write it as minus L. So this is 2 omega t divided by 2. And then I will get an expression 2a naught sine kx cos omega t. This is the final expression that I am getting. This is the final wave that you get. Now look at it very carefully. Do you see any kind of term which is like kx plus or minus omega t?
No.
There is no term like that. Then is the wave moving? When will the wave move? Only when you have a term like kx plus or minus omega t. Some function. If you don't have this, then is the wave moving? It's not moving. So that means this wave has zero velocity. Velocity equal to 0. If velocity equal to 0, then such a wave is called a stationary wave or maybe standing wave. Yes? So very interesting stuff that if you have two waves which are traveling in opposite directions now, they meet at a point, then they will create a wave which is not moving at all. Not moving at all. Its velocity is 0. Yes? And let's assume this. So I'm going to call this 2a naught sine kx as some modified a, which is a function of x. Yes? And what will be the y written as? A as a function of x cos omega t. Now what do I mean by stationary wave or what is this? Let's try to imagine everything as we go on. So let's try to imagine. One of the ways in which you can make a stationary wave, you can do it at home as well, is let's say you have a rubber band and then you रबर बैंड के दोनों एंड्स को ऐसे प्लग ऐसे वो कर दो, नेल कर दो दो एंड्स पे. Now you have a rubber band like this. What you do? You plug here. से करो. How will the wave move? एक ऐसे ये एंड नीचे हो जाएगा, ये ऐसे एंड हो जाएगा. Yes. Then this will create one wave. This wave will go and hit the wall. Okay? Now understand this. What is happening? When this is the wave, then the particles are basically pushed upwards. From a mean position, they are pushed upwards. As it goes and hits the wall, then the wall will. So it's like a force upwards. A wall will provide a force downwards. It's a reaction force. Yes or no? The reaction force. And how will the reaction force be? Downwards. So that means the particles are now forced downwards. So how will the wave now go? It will go like this. So can you imagine if I pluck one of the rubber ends, then the rubber end goes like this, then it goes like this, then it goes like this? Yes? Keeps on going like that. And can you imagine that you have one wave which is traveling in one direction, then you have another wave which is traveling in this direction. That creates a stationary wave. Now very, very interesting things happen here. So what are the difference between a stationary wave and a traveling wave? Let's say you have a traveling wave yx. Okay? I have a wave like this. These particles are oscillating, huh? These particles are oscillating. What about this particle? Will it oscillate? I'm not fixing time or anything, huh? Will it oscillate? Can you tell me that? No. How many of you say no, that the particle will never oscillate? Never oscillate. What about as time moves, so the wave moves with it? The wave will move, and how will the wave move? Let's say अब ये wave इधर आ गया. अच्छा, when the wave moves, the particle do not move, ना? They only perform oscillation about that. So now is this particle oscillating? Yes or no?
Yes.
और ये जो पार्टिकल पहले ऑसिलेट कर रहा था, अब वो इधर आ गया. And now if you really want, you can even check कि और आगे बढ़ोगे, then ये पार्टिकल भी ऑसिलेट करेगा. Then is there any position throughout the medium in which the particles do not oscillate at all? No. As the wave moves through the medium, all of the particles will oscillate after some time. They will all oscillate after some time. Now let's talk about here. Let's come back to here. What about the particle which is sitting here? Will that oscillate?
No.
It will never oscillate. What about this?
Same.
That will never oscillate. What about this particle? Can you say something about this?
No.
As the wave, so wave is like this. Now it will go like this. It will go like this. It will keep on occurring like that. But will this particle ever move?
No.
That will never move. So you have some particles which never move in this medium. They always remain at their mean position. What about here? You always have some kind of oscillation. Yes or no? First thing. Second thing, why did I write this AX? Why did I not leave it at 2A0? Why did I write it as A as a function of X? Now listen to this again carefully. You have the wave again. You have this wave. And you have something like this. This particle oscillates, its maximum oscillation, maximum displacement is this, no? What about this particle? इसका ये है, इसका ये है. Then can you comment upon the amplitude of oscillation of these particles? Which one has the highest?
The
So this one has the highest amplitude. This one has lower, and this one has lower. Is that in general true?
No, because it lost it.
It will?
It changes its position by time.
No. The wave moves. Do you understand that this particle is only here because the wave is here? As time passes, where will the wave be? Maybe the wave is here now, and now what is the maximum possible oscillation it can do? Exactly same as that. What about at some other time? At some other time, now what happens? ये भी same कर पाएगा? So all of the particles have the tendency to have the same maximum oscillation, same maximum displacement. It's just at different times you may feel like they don't have, but as time passes, they all have the same maximum oscillation. Yes or no? So the maximum oscillation or the maximum displacement of the oscillation, that will be the constant for all of them. It may look like that is not true, but that is true because the wave is moving. What about here? Will all particles that are oscillating, will all of them have the same maximum amplitude? Try to think. इसका ये है, इसका ये है, इसका ये है. This particle, let's say this position x3, this particle position x2, this particle position x1. Do you think there is a possibility that all of them will have the same maximum displacement? Could never happen. It could never happen. It could only happen if this wave were to be moving. Then you say, okay, this has a possibility to come here. But now it doesn't have that. So that means for a given position x, there is a perfectly definable amplitude which is fixed of that particle. So इसका ये जो amplitude है, this will never go here. That will remain there. That is fixed. For a given x, that's the maximum possible amplitude of that oscillation. What about here? Here, that will be different. So your amplitude is actually a function of x. That's why I wrote like that. Do you understand the difference between them? Can you imagine what is happening? Again, listen to this carefully. Even though the wave is not moving, see, the wave will remain here. It will not keep on moving. But are the particles not moving?
Particles
They are moving. They have some velocity. The wave has zero velocity, but what about the particle velocity? That's non-zero. What about the particle acceleration? Even that would be non-zero. So please don't confuse the two things. The particles are moving. There can be some positions for which the particles will never move. Even that is true. But now, do you get the picture? What is happening? This is a standing wave. If you want, you can do this experiment at home. You can even have two friends holding the ropes and one of them plucks like that. You'll come back and you can do it in a rubber band. You pluck it anyway and you will find that station. Okay. So I will write all of these points, but let's try to see. So your amplitude is a function of x, no? So your ax can be written as 2a0 sine kx. At what positions do you find this amplitude to be 0? If ax equal to 0, that is, so 2a0 is not a 0 value, no? The sine kx has to be 0. Then what is the condition or what are the solutions to this equation?
x0 to pi.
Give me a general solution.
Kx equal to 2n.
2 n pi?
No sir, only n pi.
N pi will work. So kx equal to n pi. And what is the restriction on n?
0 to infinity.
Could be n equal to 0?
Integers.
Integers, in general integers. Plus or minus, both of them will work. So n equal to 0, plus or minus 1, plus or minus 2, could be anything. This is the condition. And then I think k can be written as 2 pi by lambda. 2 pi by lambda, x and pi. And then what will you get? You will get ye pi there, na? So x equal to n lambda by 2. Now let's check if whatever we studied and the formula that we are getting is it correct or not. Do you remember the graph that अच्छा ये जो मैंने बनाया है that is not. देखो अगर मैं बीच में प्लग करूंगा तो फिर वेव ऐसी बनेगी और उसके बाद ऐसे आएगा लोग. अगर मैंने बाजू में प्लग किया तो फिर ऐसा आएगा लोग. These are normal modes. We will talk about that later. But let's try to see case by case. अगर मैंने बीच में प्लग किया, if I plug it at the middle, then what are you finding? At what positions do you find zero amplitude? So if this is the origin, x equal to 0 यहाँ से start होता है. Then at x equal to 0 you find a zero amplitude, ना? What about this position? What is that?
Pi.
This is 1 lambda. Then what is this?
Lambda.
Lambda by 2. Then can you see that n equal to 0 पे एक मुझे नोट एक आया जहाँ पे 0 एम्पलीट्यूड है. n equal to 1 पे भी एक आ रहा है. Yes or no? If you really want to check for other things as well, we can do that. Let's say कि I have a diagram like this. At what positions do you find zero amplitude? एक यहाँ पर, यहाँ पर, यहाँ पर. What is this length?
Lambda by 2.
ये length कितना है? Total?
Lambda.
10 lambda. एक lambda by 2 एक lambda. तो n equal to 0 पे एक है, एक n equal to 1 पे है, एक n equal to 2 पे है. Do you see? At all those positions do you find zero amplitude? So the positions at which you find zero amplitude, they are given a special name. They are called nodes. Okay? So these points are called nodes. Is there any problem? Positions at which particles have zero amplitude are called nodes. Nodes. Is it okay? I talked about the zero amplitude. That is the minimum possible amplitude of oscillation. Na? The particle is not moving at all. What could be the maximum possible amplitude here from this equation?
Kx is 1. N pi by 2.
N by
Right. If this value is 1, then you will find the maximum possible. What is that?
Kx is N pi by 2.
N by
No, don't give me the condition. Just give me the maximum amplitude.
2
2 a naught के लिए फिर if ax equal to 2a, then what is the condition? That means sin kx has to be 1, na? Yes. Then what is the condition on kx?
N pi by 2.
N pi by 2. Will it work? And what are the n? Define n. Can it be any integer?
No, positive integers.
Positive integers. Will it work for n equal to 2? N pi by 2.
Odd.
It will not work in general. तो ये बताओ कि I think odd multiples of pi by 2 will work.
1.
Yes or no?
Yeah.
I think pi by 2, 3 pi by 2, 5 pi by 2 पे ये condition चलता है ना?
Yes.
So what should be the equation?
N odd.
Odd multiples. That means 2n plus 1 pi by 2. Yes, odd multiples. And then what is the n? 0 plus or minus 1 plus or minus 2 and so on. अच्छा, what is k defined to be? Please remember the condition on n as well. What is k defined to be? That's 2 pi by lambda x is equal to 2n plus 1 pi by 2. Yes? So ये pi गया, and then what is the condition on x? What is the condition on x? I think x can be written as n plus half lambda by 2. Please check my calculations. N plus half lambda by 2. And at these positions, what am I claiming? That your amplitude will be maximum. Let's check if this is correct or not. So do you remember the diagram we had? ऐसा कुछ ना? This is one of the possible standing waves. Then what is this position? This was what?
Lambda by 2.
So this will be
lambda by 4.
lambda by 4. So at n equal to 0, are you finding a position? N equal to 0.
Lambda by 4.
Lambda by 4 आया. At that position, what do you expect? Maximum. Are you getting maximum at that point? Good. एक और करके देखते हैं. कि ये एक पोजीशन है, फिर उसके बाद ये भी एक पोजीशन है. ठीक? What is this position? बताओ.
lambda by 4.
Lambda by 4. और ये कितना है?
3 lambda by
3 lambda by 4. Everyone agrees? बताओ. n equal to 0 डालूंगा, then I am finding the solution. n equal to 1 डालूंगा, then am I finding? Yes. So at these positions, am I finding the maximum amplitude?
Yes.
Yes. So did you get the sense of what is happening? You could equally write 3 lobes, 4 lobes, and all of them. We will talk about this. We'll have a separate discussion on normal modes later. But ये समझा क्या चल रहा है? Great. Then these positions are called positions at which particles have maximum amplitude. These positions are called antinodes. So पहले nodes तो antinodes. ठीक है? इसको भी मैं कैप्स में लिख देता हूँ. Is there any problem here? Did you all understand what is happening? We actually found the positions at which you will find the maximum displacement and the minimum displacement as well. Yes? Pictorially, can you imagine what is happening? You can do this experiment at home if you want. Plug the thing at different points and you will find this thing. Okay. So these were nodes and nodes. Acha, what could be the distance between a node and an antinode? Can somebody tell me that? So, acha, what could be the distance between a node and a node? Another next node को क्या बोलूँ? Adjacent node. Adjacent node बोलते। ये शायद से मेरी इंग्लिश गलती है। एक नोड और दूसरे नोड के बीच में डिस्टेंस कितना होगा? Can somebody tell me that?
Lambda by 2.
It should be
Lambda by 2.
lambda by 2. Yes. Why? Because it is substitute this term. N lambda by 2. Take n equal to some n plus 1 n. Take the nth node and n plus 1th node. Distance between, let's say, nth node and n plus 1th node. What is that? Nth node, n plus 1th node का वेट कितना आएगा? n plus 1 lambda by 2. और nth node का कितना आएगा? n lambda by 2. तो ये कैंसिल होएगा क्या कुछ? हाँ? And what do you get at the end? Lambda by 2. There's a distance of lambda by 2. What about the distance between nth antinode and n plus 1th antinode?
Lambda by 2.
Again lambda by 2. Can you do that? What will be the distance between the nth node and nth antinode? Distance between nth node and nth antinode. ये वो antinode वाला को लिख लोगे क्या तुम?
Yeah, will.
Nth antinode है बताओ। तो if you actually see तो हमेशा स्टार्ट किससे होता है? हमेशा एक नोड से स्टार्ट होता है ना। तो नोड के बाद एंटीनोड मैं लिख देता हूँ। नोड के बाद एंटीनोड आता है, फिर नोड आता है। यानी अच्छा नहीं। तो डिस्टेंस बिटवीन n एंटीनोड एंड n plus 1 नोड लिखना चाहिए। ऐसे तो कुछ फर्क नहीं पड़ेगा। The distance will remain same, but simplification जरूर होगी। बताओ क्या होना चाहिए? n plus 1th नोड का डिस्टेंस कितना है? n plus 1th नोड का
N plus 1 lambda. N plus 1 lambda.
n plus 1 lambda by 2. And what about the other one?
N plus 1 by 2 lambda.
Should be what?
N plus 1 by 2.
n plus half lambda by 2 ना this time?
Yes.
n plus half lambda by 2. तो ये कोई कैलकुलेशन करके बता सकता है what it should be? I think you will get n lambda by 2, n lambda by 2 cancels, but still let me write everything.
Lambda by 2.
This lambda by 4. तो
Lambda by 4.
lambda by 2 minus lambda by 4 कितना होता है ये?
Lambda by 4.
Lambda by 4. Then answer is lambda by 4. So you should remember these points, okay? So ठीक है? Did you understand everything? Great. So I want to write one note before going forward. So is it written till here? Please write the antinode वाला for yourself. उसको incomplete पर छोड़ देना कि हाँ इसे obvious से लिख दो। अगर है तो लिख लो। नहीं लिख रहे हो? लिखो। No, all that. What is? So it will keep on like this. ये बोलते रहेगा। But ये time के आगे if you want to, do you want to see a video on stationary wave, how it looks like?
Yes.
Huh? Is it written?
We'll pause it.
Sir,
Sir,
we'll pause it.
we'll pause it here.
You will?
Pause it.
नहीं कॉपीराइट कर लेगा क्या? ओह ऐसा कुछ हो
Show in YouTube, in YouTube.
ठीक है पॉज करो यार क्या ही होता है ठीक है anyways so that was the animation now I want to write one note so if you remember at the start of derivation I took very few specific waves that you have a naught sine kx minus omega t the other was a naught sine kx plus omega t but it need not be like that. From that we found the expression. What was the expression that we found? YR as A naught sine. अच्छा 2 था ना इधर kx cos omega t. We found this expression, but it need not be this the only expression. You can have equally cos kx minus omega t, cos kx plus omega t. You can start off with these two waves and then superimpose and find the answer. You can even have sin kx minus omega t, cos kx plus omega t, and then you will have different final forms. So let me write all the forms. So एक sin और एक cos है. अब इस दूसरा क्या हो जाएगा? एक cos एक sin. फिर एक ये भी हो सकता है कि sin kx sin omega t. You can even have cos kx cos omega t. Did you understand the point that I made? The initial two waves that I took can be anything. If you remember at the start of it, I started off with sin kx minus omega t, sin kx plus omega t. You can start with cos kx minus omega t, cos kx plus omega t. Or you can start with same but here cos, this same here cos, and then you will have different expression of starting waves. Remember that the position of nodes and antinodes that we found, these positions that we found were only true for this one, this one. But if you encounter these waves, then please try to do it yourself. You know how to do it now. Just put the ax equal to 0 one time and ax equal to 2a naught, you will find the condition, the points at which there will be nodes and antinodes. So these are possible expressions of standing waves. Please remember the node antinode position that I found was for this first one only. For others, you have to do it yourself. Try to see it. Okay? In the sin kx wala term, I think it will be the same as before, but cos kx में check करना है. Is it okay? Great. So we have talked about these things. Let me see. Yes, I want to write this difference between अभी 5 साल के बच्चे जैसे ये सब लिखता हूँ अभी मैं कि difference between standing wave and traveling wave. ठीक है? I talked about some points already that traveling waves have a constant, the maximum possible amplitude the same for everyone, but here you have a function of x, and also I said कि all the particles in traveling wave oscillate. Here some particles do not move at all, nodes, है ना? And then there are some other differences. तो वो सब लिखेंगे चलो. Traveling wave, standing wave. And the first point is I have to talk about one more thing. Let me write everything, then I will explain. I think some of the points I have already explained, but ये second वाला बताना है. You sit here. I think तुम चारों में मैंने position change किया था ना. Don't sit there where you are sitting. You are supposed to sit at the back. Go sit. Go back. Sit. So please write and then tell me. I will have to explain the second and third point. जल्दी जल्दी आ चलो. then? Great. Now let's talk about the second and third point. I have written here that at any instant, that means you're fixing time. That means which phase difference you're talking about, by the way? Fixed time?
Spatial. No. It's spatial.
Spatial phase difference. You're talking about spatial phase difference. This delta phi s is 2 pi by lambda delta x. So between any two particles, if you remember, we were actually comparing two particles. And for temporal phase difference, we were comparing the same particle at different times. But anyways, now between any two particles, if you look at it, you have this wave. Let's say this particle is at some position x1, this particle is some position x2. Understand this, the phase difference between them can be any value, no? Depending on the delta x between them. Yes or no? What was delta phi s equal to? This 2 pi by lambda delta x. If I consider this particle and this particle, it may have different phase difference. What about this particle and this particle? Some other phase difference. Yes or no? Because the delta x is going to change. And then you will have different values of delta phi s. And what could be the minimum possible value? When there is no phase difference, that's 0. And when will you have the maximum possible value? When you consider this particle and this particle. The maximum possible phase difference, 2 pi. Yes? So you can have any values between 0 to 2 pi. Any values. What about here? When you have a standing wave, so these are the particles which are oscillating. ये ऊपर oscillate किया, and at the same time ये particle कहाँ oscillate कर रहे हैं? नीचे. Yes. Then for a given time, what do you think? This particle and this particle are always opposite to each other, no? Always. They are always out of phase. When this moves up, this moves down, always. Yes or no? If I take any particle from this lobe, and any particle from that lobe, every time this goes up, the other will go down. So what is the phase difference between them? That's pi. Always out of phase, no? What are the particles which are here? They are always going together up. So what is the phase difference between them? 0. Should be 0. So what are the only two possible values of phase difference?
0 and 2 pi.
That's 0 and pi. Did I write 2 pi? That's incorrect. It should be pi. Should be pi. So usko thoda correct kar lo.
That was a pi.
No, that's 2 pi. Okay? So the only possible values of phase difference is either 0 or pi in this. What about here? Acha, will this pi, so what does a traveling wave do, or in general how we define a wave? A wave is a disturbance which carries energy and momentum from one point of space to another point of space. It carries some energy. No? What do you think? Will the standing wave carry some energy?
It's always same, so
It won't? Are the particles oscillating in standing wave?
No.
particles are oscillating.
The particles oscillate. They are performing SHF.
Yes.
Do they have some kind of energy in them? Yes. So the wave will also have energy. But the important thing is, will it transmit energy from one point to another? Can it transmit? No, because it's not moving at all. But what about a traveling wave? It can move. So it can move, transmit energy from one point to other point. So they both have energies, but this cannot transmit. Is it okay? So now that we are done with this discussion, there's only two more discussions that are important. There's a discussion on resonance and one of the other ones. I don't remember the other one. But that two we will do. And normal modes. We'll talk about normal modes next time. These two we will do, and that will be the end of the chapter. But today let's do some problems. So take the first problem. normal questions. We'll do some good questions in the sheets. For now, these are just warm-up questions. Did we do this question last time?
Yes, sir.
We've already done it.
I went somehow.
I did not phrase the question exactly like before, but ये कर दे, वो भी कर दिया ना वो अल्फा वाला,
yes, sir.
अल्फा वाला भी कर दिया. So let's do some other questions then. I'm giving you all simple questions today. We will do something interesting next lecture always. So, I'm giving you 3 minutes, then I will start. So at 12:57 I will start. What are the values?
1 by 4 by centimeters.
Just
15 by 8.
No, V is 60 centimeters.
That's correct. What about VP?
Minus 12 sine by the sine.
60.
Correct. Very good. So should I start with the question?
No, sir.
Great. Should I wait?
Yes.
Okay. Those who are attempting, keep attempting. And don't just wait around for the solutions. Okay then, start. They are asking about the frequency, but I think this relation looks to be like A sine kx cos omega t, no?
Yes.
Then what is omega given to be? 30 radians per second. That's 2 pi. Then what is that? 15 by 5. This is very simple. And I think k is also given. K is given to be 0.5. X is in terms of centimeter, then k will be in terms of inverse. And that is equal to 2 pi by lambda. Then what is lambda equal to? 4 pi centimeters. Yes. Now what is V? V equal to F lambda. But why am I talking about V? Isn't this a stationary wave? Why am I talking about a velocity? And you also got some velocity value.
Particles.
Motion of
This is not VP, this is VP. How did you find a velocity for a stationary wave? वो सब मुझे पता है, फॉर्मूला मुझे पता है. नॉन जीरो कैसे निकल के आ गया? That's why you should read question very carefully. It's given you should find all of these things for what? Component waves, the waves with which we started off with, not the final wave. They were moving with this velocity. What was this? So V equal to F lambda, 16 by pi into 4 pi, and what is this equal to?
60 centimeter.
60 centimeter per second. So this is V. What about the VP? How to find the VP? VP is equal to del y by del v. Take the derivative and tell me the answer. So cos का derivative will be minus sin, ना? So this will be minus k omega sin kx cos omega t. Yes or no? And then what are the values of k and all these things? Let's substitute. So Vp will be, what is A? What is A?
0.
0.4. K. Omega 30. And this will be 0.4 times 30 is what now? 4 by 10. So 12.
12.
12 is na?
Yes.
12 sine 0.5x cos 30 t. Now they have mentioned some position and some time at x equal to what?
2.4.
At x equal to 2.4 centimeter and t equal to
0.8.
seconds. What will you get Vp as?
minus 12 sin 1.2 cos
So 0.5 into 1.2 हो जाएगा नहीं?
cos
Cos 24 t. That will be centimeter per second, है ना? Is it okay?
Sir, can we use that section V like because it's
माइनस
also
ओमेगा रूट ऑफ इस करने से you could use that because the particles are oscillating. Yes, you should be able to use that.
So
Did you get the answer?
yeah.
So in the first one it should be plus or minus 60 centimeters.
Plus or minus 60, yeah?
Yes.
Yeah?
They are asking of the component waves. We'll get.
Yes, yes, could be anything. What if I ask speed now?
Plus.
Speed हो जाएगा? Speed है वो. ये speed है. Yes, that can be plus or minus 60. Let me write the next question. Every time I give a question, it would be much better if you spend some time to try to actually do it. Rather than looking ghosts at the ceiling. No. These are again very simple questions. So attempt them. I will start at 107. Joel, go and sit at the last bench. You go and sit back. Or rather, here the last bench. Both these are last bench. तो कैसे है? I did not mention this. The length of string is 60 centimeter. So this y is created as some string. This y is created as some string, a rubber band can be some. एक साथ जाते हो ना? इसे बैंड में जाते हैं क्योंकि ये लोग टाइम पास करने को जाते हैं। Yes, costly है बेटा। Should I start myself?
No, sir.
Not that hard. What is the value of y max? Anybody?
2 root 3
cos pi
96 pi 2.
That's not y max. Talking about y max.
2 root 3 centimeters. 2 root 3 centimeters.
That's correct. 2 root 3 centimeters. That should be y max. What about the positions of nodes?
Maybe 7.5 centimeters.
7.5. No, that's incorrect. There can be multiple position of nodes, not
Yeah, at least 7.5 centimeters. So then 7.5.
7.5 is the wrong interval. You're missing by a factor.
Sir, 0, 15, 30, 40.
Yes. It's 15, not 7.5. 0, 15, 30, 45 and 60. These are the positions of the nodes. What about BP?
Minus 384 pi cos 24 pi.
Minus 384 pi
Cos 24
cos 24.
pi.
Incorrect. Should I start with the question? चलो मैं स्टार्टिंग का करता हूँ, तुम लोग करते रहो, C and D पार्ट अटेम्प्ट करते रहो। So minus 384 is
Sin pi by
minus 384 pi
sin pi by
sin pi by 2 और कुछ नहीं है
cos
Cos
24 pi.
cos 24 pi नहीं sin 24 pi that's correct it should be minus 384 pi sin pi by 2 sin 24 pi not cos 24 pi and what will sin 24 by pi be that should be 0 so vp will be 0 चलो करते हैं so y is given this then y max so let's talk about at x equal to 5 so a part at x equal to 5 what is y 4 sin 5 pi by 3 हो जाएगा ना और cos 96 pi t yes what is sin pi by 3 equal to that's root 3 by 2 and that will give you 2 root 3 and then what will be the maximum possible displacement that's this amplitude which is sitting in front of it na? so y max is equal to 2 root 3 ये तो बहुत सिंपल था and then b part for b part what do you have to do positions of nodes that means at all times what are the positions of nodes so y is given to be what y is equal to 4 sin क्या है pi x by 15 है क्या cos of 96 pi what are so do you remember that the nodes do not move at all so as time passes ये nodes का position भी नहीं बदलने वाला है so that means at all times what should be the condition what should I make equal to 0 this should be equal to 0 na for nodes that's the condition of nodes but is this 0 or that 0 this is the thing which is 0 why am I not taking this to be 0 because I am talking about at all times let t be a variable ठीक है so at all times what is this sin of pi x by 15 is equal to 0 that means when will this occur n pi pi x by 15 equal to n pi तो ये pi pi बेटा तो फिर x क्या हो जाएगा 15 है 15 के इंटरवल्स में and then what can the n value take so यहाँ से यहाँ तक ये वेव बन सकता है 60 सेंटीमीटर का ये मेरा स्ट्रिंग दिया हुआ है that what are the possible values x equal to 0 n equal to 0 पे n equal to 0 पे x equal to 0 n equal to 1 पे x equal to 15 n equal to 2 पे x equal to 30 is this correct please check
yes
and this will end at this point na you can't go beyond 60 centimeter because that's the end of the string these are the positions of the nodes at all times now what is the third part for the third part you have to find Vp but what is Vp just del y by del t now you just have to differentiate then what will you get what was y by the way y bolo
4 sin pi
4 sin
pi x
pi
by
x by 15 96 pi t now if you look at it carefully this is partial differentiation so it will not have any effect on this term but what will the derivative of cos that's minus sign there will be a chain na? So 96 times 4 is what 384 sin pi x by 15 sin 96 pi t but now they are asking to find the velocity of the particle at given position and given time and what is the position given to be what is the position given
7.5
7 point
7.5 centimeter and Time is
0.25 seconds.
0.25 seconds. Okay. Then Vp is equal to 7.5 pi divided by 15 sine of 96 pi into 0.25. Now can somebody tell me ये तो 1 सा ये 2 सा में गया तो pi by 2 हो गया 96 times 1 by 4 what is that equal to
24.
24.
then what do you get sine pi by 2 that's equal to 1 but sine 24 pi so what is sine 24 pi that's 0 any multiple of pi in sine is 0 so that means you get 0 so we equal to 0 can you write the last wala yourself huh? Can you try the last one yourself take it as a homework and if you have completed with this then we take it